Hello everyone, once again to this particular new lecture where we're talking about PMC instrument. It is one of the instrument of a electromechanical type where we use the principle of permanent magnetism. One of the major instrument of this type we will use as a de-arsinometer. The construction should be different in some type as we do not use the mirror in case of PMC meters. And most importantly, as we see in de-arsinometer, they work only on DC. Permanent magnet type or PMC instrument also only work on DC measurement tools or DC sources only. Where one of the more moving coil instrument, that is called EMC instrument, or we can say dynamometer type instrument, they work in both AC as well as DC meters. This particular working of your permanent magnet moving coil, considering that we consider two type of, we provided a force using two type of mechanism. First is permanent magnet containing north and south pole, and other is moving coil. Okay, we will providing the force using the two type of construction mechanism. First is permanent magnet and second is moving coil. Okay, so what should be a construction? As you see in your particular slide or in your video also, as you see in your left, right, it is a 2D diagram. We will represent it that there should be some north pole and there should be other side should be south pole containing a permanent magnet. In the other electromagnetic type, we will use replace this permanent magnet by electromagnetic coil, but in case of PMC meter we use some permanent magnet only. In between them there is a core, or it is a aluminum former that should be moved or attached to a pivot or jewel, which will be moving as the force should be there in the particularly in this moving coil system. This particular aluminum former, it should be wounded by a copper wires of thickness depending upon you act as a ammeter or your voltmeter, and this particular construction of wire should be attached, as you see in your right hand side also. This particular aluminum former containing some wire should be wounded around it. It is attached one of the medium through the upper spring, attached to the upper spring, and one of the coil other part should be attached to the lower spring. It is one of the important fundamental such that the moving coil carrying current carrying conductor should be attached to upper and lower springs. Okay, now moving toward that, this upper and lower spring act as a controlling force or controlling torque that oppose the motion of deflection, bringing the pointer to be zero. And in other part, this particular PMC meter uses electromagnetic damping for its use only. So as the force should be provided in your PMC meter, the pointer should be deflected on your scale. Okay, there is a simple as it is system where there should be some spring shown there, and there is a pivot bearing on which the particularly all the moving system should be fixed. It's one of the diagram from upper parts can be see like this. From the upper view can be see like this. There is a north and south pole, that is your north and south pole, that is your moving coil meter having carrying the conductor on a aluminum former attached to showing some pointing on the indicating instrument. And some of the more measuring thing, we will suggest that in case of your electrodynamic meter, we can also use balance weight system or gravity control in that particular system also. Now next thing, that is construction wise, as we say, particularly assembling diagram or a particularly construction views, you can see it is a basically the aluminum former is circular in form. Okay, as is it circular in form, the winding is in the rectangular form. It is very important as per PMC instrument that if the aluminum former on which it is basically a device where you wound your particular coil, if it is a circular in shape or it is cylindrical in shape, if this particularly core, aluminum core is cylindrical in shape. The coil you should mount it always be in rectangular shape. This particular rectangular coil will be attached to upper and lower spring, as you see in upper and lower side, and then going toward your outer connections also, where you have to wanted voltage or ammeter to be measured. And this, there should be a pointer, as you see pointing out, and upper part, that is a jewel bearing. It is a basically a pivot on which all the moving coil systems should be attached. There should be north and south pole pieces are should be there in the system. Okay, as you see, this coil is mounting on aluminum bobbin. It is rotated by 90 degree only. Okay. Now, construction. This particular one more important thing. This particular core is basically a soft iron core, and magnets should be north and south pole. Basically, they are in cylindrical shape. Firstly, the length of air gap is reduced. Secondly, in this particular instrument, the iron core help the making the field radial. It will be more air gap should be reduced, and more of the force should be formed on your moving coil system. The angle between angle of deflection is basically directly proportional to current in this particular PMC instrument, as we use only the spring contour. So what is the working principle? It is a very basic principle where we suggest that if there is a fixed magnetic field north and south pole, and there is a current carrying conductor should be placed in the circuit, if magnetic field cut this current carrying conductor, if magnetic field cut this current carrying conductor having length L, then there is a force that is called Lorentz force will be experienced by this conductor, that will move the conductor in I think so it should be in clockwise direction or anti-clockwise direction, depend by given by Fleming left hand rule. Okay, what is mean by Fleming left hand rule? Fleming left hand rule indicated that if we have the field as a north and south pole, field should be there, and the current on the conductor should be we know, then the motion of your conductor should be given by thumb using the Fleming left hand rule. Okay, this basic rule of Lorentz force uh, providing the force of direction, which will be particulated as the angle of deflection using the pointer also on the moving system. It opposes by the two spring bronze type springs that is provided contouring torque and the damping torque, as is a two type of you have choices. You can one of the choice can be AD current damping. It is very usually used, and second time then that you can take also your weight control or gravity control also. Okay, how should a deflection can be seen? As you see in diagram, as we have a conductor having the dot and cross. A dot means it will be outward toward the circuit, and cross product it will going to in the down toward the your screen also. As a conductor having the that direction, if the magnetic field will be approaching toward this magnetic field, by due to this force of direction should be developed. The direction can be given by Fleming left hand rule. Okay, so how we will develop the torque equation of this particular PMC instrument? Let us assume in the previous diagram the conductor having the PQ conductor. Okay, PQ conductor having single turn. P is the outward current and Q is the inward current. Then the force experienced by both of this conductor, as we have a from the middle of the point P and Q have the distance of d by 2, then torque should experienced by both of the conductors should be F into d by 2, F into d by 2, where F is the flux force represented by your magnetic field, and d is the width of the coil. Then as we see, the force is F equal to NIBL, that is directly proportional to current, and where net deflection force or torque will be NIBA, where A is the area of a coil given by L into D. Then deflection for torque, if we considering that number of turns are constant, magnetic field is a permanent magnet, so it should be constant. Then it will represented by K, it is one of the constant. Then we'll say that the deflection torque can be directly proportional to current. As we use the spring control, TC, contouring force is directly proportional to angle, then at the case of final or steady state angle, we will suggest that theta is directly proportional to current. Okay, as we have a uniform scale. So this type of PMC meter having the high sensitivity and high accuracy regarding a 2% of full deflection, it have a uniform scale because due to their spring control mechanism. And one of the important thing, as we use the permanent magnet for our magnetic field, there is no effect of stray magnetic field on the measurement. One more important thing, there should be high torque as the weight of the overall circuit should be low. So high torque versus high torque weight ratio should be there. So power consumption is very low. Okay, now one of the what are the disadvantages? Major disadvantage that it only work on the DC, it does not work on AC. If we work on AC, it will be fluctuated around the your true value only. Okay, as compared to other type of instrument, they are the expensive. As I say, the one of the major disadvantage of control spring we use, it will be reduces during its aging process should be there, and it causes some error in the system. And second point, as the thin and light wire are will be used in this particular moving system, the current capacity of this coil is very low, hence low torque to weight ratio will be there. And for expanding its particularly range, we will use some of the other condition like range extension methods also. So minimum maximum current that we can by this particular PMC meter are 100 milliampere only. There should be some errors like friction errors should be reduced in PMC meter, temperature error should be reduced in there is no friction error, hysteresis and stray magnetic field errors are not affected on PMC meter. That's all. Thank you so much for PMC meter. We will continue our lecture for moving iron instrument.